last video we have seen the difference between AC drive and DC drive. One more drive is adjustable speed drive. The block schematic of adjustable speed drive is as shown in the figure. It consists of converter, inverter, regulator, and last one is AC motor. Now in this case, the converter converts the AC into DC, and that DC is converted into AC with the help of inverter, and that AC, magnitude of that AC is controlled with the help of regulator. That is, the voltage control is carried out with the help of regulator, and frequency control is carried out with the help of inverter in adjustable speed drive. The name itself indicates that in adjustable speed drive we can change the speed of drive, AC drive. And as you know, the synchronous speed of AC drive or AC motor is given by the formula 120 F upon P. So speed is directly proportional to the frequency and inversely proportional to the poles. Once the AC motor is designed, the poles are constant, so variable quantity is only frequency. So that frequency you can change by changing the firing angles of the solid state devices present in the inverter. So by applying a variable frequency AC signal to the AC motor, one can change the speed. The speed above normal speed can be achieved in this type of drive, that is about 60 Hz or about 50 Hz. If you increase the frequency, you can increase the speed of AC drive above the normal speed. So when the speed is changed, what effect is observed on the torque, that you can see over here. So that power torque relationship. So the effect is observed on the horsepower. If the speed is reduced, then if the speed is reduced, that reduces the horsepower of that motor, and the reduced horsepower reduces the energy drawn from the AC source, and there is the saving in energy. So in this fashion, in this type of adjustable speed drive, you can save the energy consumption. So instead of using the other type of drives, if you want to increase the speed above normal speed or decrease the speed below normal speed, where there is a loss of power, but in this type of adjustable speed drive, there is reduction of, or there is a saving of energy. When this drive is run above normal speed, that is when the frequency of supply is increased above 60 Hz or 50 Hz, at that time that drive runs with above the normal speed. When it runs above the normal speed, at that time there is no increase in voltage, so there is reduction in the torque. So reduction in torque reduces the horsepower or maintains the horsepower. So ASDs are not capable of increasing voltage so as frequency increases above 60 Hz, the torque produced starts to decrease. So in order to maintain constant horsepower output to drive our load, the speed is increased, torque must be decreased. So at some point of increased speed, we may not be able to produce enough torque to drive the load, and at this point the motor will slow even with increasing frequency. This point is different for each manufacturer's motor and depend upon the torque required by the load. Only the manufacturers can help determine when this occurs. Let us see the advantages and disadvantages of adjustable speed drives. There are numerous advantages and disadvantages of adjustable speed drives. So let us see the advantages. There is energy saving, improved process control, reduced voltage starting, that is voltage, there is a reduction in starting voltage in case of ASDs, as is not present in AC drive. There is a lower system maintenance as there is no commutators in this type of drive. There is a bypass capability and there is multi-motor control. So what are the disadvantages of ASDs? Its initial cost is high because we need the converter, inverter, their control circuitries. There is high motor heating at low speeds. There is little bit more maintenance and more output harmonics are induced at the output, and there is induced power line harmonics. So there is need of power filter harmonic reduction techniques or harmonic reduction circuitries in this type of drive. So detailed explanation is given about each advantage of ASDs. That is, first one is energy savings, then variable torque loads with graphical representations, then constant torque loads with its graphical representation, then reduced voltage starting, it is shown over here with the block schematic, improved process control, then lower system maintenance. All these are in detail, they are given over here. You can read it carefully and let us see what is present in that. Then bypass capability, then multi-motor control systems present in the ASDs. Also disadvantages in detail they are explained over here. That is, first disadvantage we have seen maintenance, then motor heating at low speed operation details are given over here. And output harmonic distortions are present in these. They are graphically, they are waveformically represented over here. Then different ASDs are noted over here, like variable voltage input, current source input, and PWM modulated ASDs. So these are the types of AC ASDs. So depending upon how the control voltage or the current control frequencies are given to the adjustable speed drives, depending upon that they are classified in VVI, that is variable voltage, then current source, and PWM controls. Their detailed explanation is given over here. Current source inverter with waveforms, then pulse width modulation with waveforms, it is given over here. And one example is given over here, variable torque load type of ASD, their calculations, bill calculation, then plant monitoring, then energy calculation, energy consumption calculation. The detail is explained over here. Let us go to the DC motor. As I told while defining the drives, motor is the heart of drive, and depending upon the type of source or the type of supply given to the motor, they are classified into two classes. One is DC drives and AC drives. As I told, in DC drive the DC motor is used, while in AC drive AC motor is used. Let us see in detail about the DC motors. Of course, you may have studied the DC motors in electrical subjects, but let us see the review of it. What is working principle of motor? As you know, the working principle is stated as Whenever a current carrying conductor is placed in a magnetic field, it experiences